find the surface area of three-dimensional compound shapes. That means the shapes we're looking at are comprised of two or more three-dimensional shapes. Two things to point out. First of all, the diagrams are not drawn to scale. That means you must pay attention to the dimensions that are provided in the diagrams. And secondly, in order to solve these problems, you have to imagine that there is an opening between the two shapes. Okay, the face that would have been included in the surface area calculation for each individual shape will not be included to find the surface area of this particular shape. I'll explain as we go along. So first of all, in this example, we have the cylinder on the bottom and a half sphere in the top. Both shapes have a radius of 2.3. So in order to come up with the surface area, we are going to use the surface area formulas for each individual shape, but we are also going to adapt them to include or to remove faces that we will not be using. So first of all, I've already started here. We're going to take the surface area of a sphere, which is 4 pi r squared, but because we only have half a sphere, we're going to divide by 2. Then the surface area for a cylinder is 2 pi rh plus 2 pi r squared. Now I've crossed out the 2 because we only need to include the bottom circle. The upper circle that makes up the cylinder is going to be excluded from this calculation. And in the calculation that follows, I am substituting in my values for r and h. So first of all, 4 divided by 2 simplifies to give us 2. So I have 2 pi, I replace r with 2.3, carry out the 2, the pi, replace r, replace h, plus pi, replace r, and it's squared. Now it's a matter of following order of operations. So I'm going to take care of all the exponents first. So 2.3 squared gives us 5.29. In this case, I'm multiplying the 2, the 2.3, and the 5.6 to get 25.76 times pi. And again, the 2.3 squared is 5.29. And now at this point, some people choose to start replacing the pi with 3.14 and multiplying out. I prefer to work with an exact answer, so I'm going to leave pi as it is for now. All I'm going to do here is multiply the 2 and the 5.29 to get 10.58 multiplied by pi. Now, here, everything that is common, each one of these terms has a pi. So it's like the variable x, okay? Pi is a placeholder for a number. So I am going to add all the numeric coefficients, the 10.58 to the 25.76 to the 5.29 to get 41.63 times pi. This is an exact answer because pi is in its entirety, okay? So our units are meters squared. However, at this point, I am now ready to take 41.63 and multiply it by the numeric value of pi, which is 3.14, or use the pi button on your calculator, and I get an approximate answer of 130.8 meters squared. This is an approximation because I have now rounded my answer. On to our next example. This shape is comprised of a cone on the top with a cylinder on the bottom, and both shapes have a radius of 5 centimeters. The 2 centimeters represents the height of our cylinder. One thing to point out, with cones, there are 3 pieces of information that are used for the surface area. There is the height, there is the radius, and then there is this diagonal piece here, which is called S. In this particular case, S is provided for us, okay? So S is equal to 13 centimeters, and we'll be using that in our calculation. Okay, so now for the cone, only the lateral surface area will be calculated. We are not going to include the circular base. So that means our formula will be pi r times s. That is the lateral piece for the cone. Then we are going to add the piece that goes around here, which is 2 pi RH. And then we have two circles. We have an upper circle and a bottom circle on the cylinder, but this time we only include the bottom. So we have pi r squared. Okay, so that's taking care of the three faces of our shape. And now we are ready to input the information. R is 5, S is 13, R is 5, H is 2, pi r is 5. Okay, and it's squared. Okay, so I'm going to follow order of operations, taking care of exponents and multiplication. So 5 times 13 is 65. So we have 65 pi plus 2 times 5 is 10 times 2 is 20. So there's 20 pi's there, and 5 squared is 25, and that will get multiplied by pi. So again, I'm going to work with the numeric coefficients, and I'm going to add those together. So 65 plus 20 plus 25 gives us 110 pi. And that would be centimeters squared. This is an exact answer for our surface area. But if I take 110 and multiply that by 3.14, that will give us 345.4 centimeters squared, and that is now an approximation. And one more example similar to this, we have what looks like an ice cream cone. So we have a half sphere on top of a cone. Both shapes have the same radius of 5 centimeters. The upper part is going to be the surface area of a sphere, 4 pi r squared. But again, because it's only half a sphere, we're going to divide by 2. And for the cone, because it's open to the upper piece, we do not include the circular base. We only include the lateral section again, pi rs. Again, we can simplify. This is going to give us 2 pi. Our r value is 5. And our r value is 5, but we've got to figure out s. We haven't done that yet. What is s? So let's have a look at our diagram. This here is 12. And so this here is the question mark. That is s. There is a right triangle here where the height and the radius meet. And because s is the hypotenuse of a right triangle, we apply Pythagorean theorem. So we're going to get s squared equals 144 plus 25. S squared equals 169. So s equals the square root of that, which is 13. So our value for s now we can input is equal to 13. So this will be 2 pi times 25 plus 13 times 5 is 65. So we'll have 65 pi. That's going to be 2 times 25 is 50 pi, 65. And when we add those together, we get 110 pi. And that's our exact answer. And then we have to multiply that. It's interesting, we got the exact same answer as the one up above. That is just entirely a coincidence. So 50 plus 65, 50 plus 65 is 115. That's my mistake. 115 pi times 3.14. So our approximation is 361.1, and our units are centimeters squared. Okay. So the three examples that we've looked at so far have common pieces. So in all these cases, the shapes shared a common radius. Okay, and the opening piece matched up exactly. Okay, so this was a circle that was common. There was a uniformity into where the two shapes mixed up. In our last example, things are going to be a little bit different. So in our last example, we have a rectangular prism with a cylinder on top. And so when we calculate the surface area, we're going to calculate the surface area of each individual shape. So we'll take care of the rectangular prism and the cylinder separately, and then we will combine those values together. Now, again, there's an opening between the cylinder and the rectangular prism. So this circular piece here needs to be excluded for both shapes from their surface area. So I've started by writing out the formula. So the 2 pi RH takes care of the rectangle that makes up part of our cylinder, and we're only including the upper circular piece, the circular face, we're excluding the bottom. So we're going to do 2 pi, our R value is 4 for this, and the 8 here represents the height. And our radius is 4, and we square that. So that'll be 8 times 8 is 64 pi plus 16 pi. And we'll add those together. 64 plus 16 gives us 80 pi. And so that's an exact value for the surface area of our cylinder, excluding the bottom. Now, down below, I've already started with our formula. This is the formula here for the surface area of a rectangular prism. But what we need to do is we have to subtract this circular face where the two shapes meet up, which is just a circle, pi r squared. Okay, so this is our length, our width, and our height. So our length is 14, our height is 12, our length is 14, our width is 8, and then we're going to have W, which is 8, times height of 12, and our radius of our circle is 4. So now we're going to clean this up. So I have to get out my calculator. 14 times 12, 168, 14 times 8, 112, and 8 times 12 is 96. And this will give us 16 pi, because 4 squared times pi. I'm going to clean up what's in the brackets. So 96 plus 112 plus 168 gives us 376 minus 16 pi. I'm going to multiply that by 2. So it's 752 minus 16 pi. Again, exact answers. So now we're going to combine the two shapes. So we're going to have 80 pi plus 752 minus 16 pi. So that's 752, and 80 minus 16 is 64. And our units are feet squared. Sorry, it's in metric, or sorry, in imperial. And this is an exact answer. And what we can do from here is we can replace the pi with 3.14 and multiply that by 64 and add back in the 752. And so an approximate answer is 952.96 square feet. Okay, lots of work to do. Take your time, think it through.